everyone, I am Dr. Shelby Rader, and I am a trace metal geochemist here in the Department of Earth and Atmospheric Sciences at Indiana University. So as a trace metal geochemist, that means that I look at metals at very, very low levels, predominantly in geologic material like rocks and minerals, but also in some biologic material in an attempt to understand how geology may play a role in the distribution of some metals in our environment. So when I say I look at things in trace levels, what I really mean is that I look at element concentrations that are in the part per million or even part per billion range. So for every million atoms that I try to analyze, the things that I'm interested in may only be present a handful of times. So it's very difficult to do, but it's incredibly rewarding that we can do it. So today I'm going to take you through a day in the life of a lab trace metal geochemist. So let's go.
So the first step with any sample is to take it and break it down into smaller and smaller pieces. This helps increase the surface area so we can go from a solid rock into something that's a solution. So you can see me doing that here with what we call a mortar and pestle, where I take the sample, I place it in this metal container, and then I smash it with a hammer, which is a lot of fun. You'll also see a lot of cleaning in between, and again, this is because we're so worried about contamination between samples, but also from things that may be falling out of the air. Once we have our sample crushed, then it's time to weigh it out. Here we have to be really precise and really careful because this is how we ultimately determine what the concentrations in our metals are. It all depends on how much we weigh out. So you can see this is kind of a labor-intensive process, and again, you have to be fairly careful and avoid contamination, but it ends up resulting in some really neat work. Once the samples are weighed out, they're ready to go to the clean room, but before that, we have to get dressed up in something fancy.
So because the metals I'm interested in are present in such low concentrations, we have to be really, really careful about contamination. So you might expect, since I'm interested in metals, that my lab has to be metal-free, which is true, and I'll show you that in just a minute. So everything inside is wooden or plastic or some other type of material, but no metal anywhere. Now the other thing we need to worry about is metal contamination from things that we may bring in ourselves. This can be anything from dust on the bottom of our shoes to particles on our clothes and even our hair. So this is why I get to wear this pretty sweet setup with the hairnet and these beautiful, beautiful clean suits.
Once I'm ready to go into the clean lab, the samples come with me. So the next step is to start what we call the dissolution process. This is where we use a mixture of acids to actually break down a solid rock into a solution, which is absolutely crazy. We're able to take something that is very difficult to break, even with a hammer, and completely dissolve it into something that we then can put through columns, which you'll see in just a minute, and ultimately measure different element concentrations out of it. So this is an incredibly, incredibly neat experience, and something that I personally enjoy, even though I've been doing it for years now. Once the samples have the acid added to them, they then go on a special hot plate. This hot plate's actually made out of a Teflon coated block of graphite, the same thing that's in your lead pencils, which is pretty wild. The graphite allows for things to heat up at a really consistent temperature, and so by adding heat to these samples, it helps us to break these down. Again, we're going from incredibly hard, solid materials, things like rocks and sometimes plants, into a pure liquid, which is really, really amazing. Once our samples have been dissolved and they're a pure liquid, then we run them through columns for purification. You can see the columns here. So at the base of these columns is a resin, which essentially is just little tiny beads that have different affinities for all the different elements on the periodic table. What this means is as a solution drips through that resin, all the elements that were in that rock connect and bond with this resin. It's like they're hugging it almost. And by using a different series of different acids and different concentration solutions, I can actually selectively remove different elements at a time. So I can take a rock that has little bits of almost every element on the periodic table, run it through these columns, and pull out a solution that has just a single element in it. So I've completely purified it. Again, this is really mind-blowing. Once we've purified our sample, then we're ready to run it on what's called a mass spectrometer. The mass spectrometer allows us to measure individual elements down to parts per trillion levels. So for every trillion atoms that we pass through it, We only need one or two of the element that we're interested in to be able to measure it. So again, we're going from a really hard solid rock into a solution, into something that's purified sometimes to just a single element, and then we're able to accurately measure that down to the parts per trillion level. So geochemistry is incredibly powerful to tell us a lot more about the Earth as it is now, as it was in the past, and how we can expect it may be in the future.